During a visit in March, the stake was nearly buried, with just a few feet left above the drifts. And just a few steps away, even the summit monitoring station we had visited in the summer was all but swallowed by snow.
Hi, I'm Amy Finley, and this is Across the Fence. Today, we bring you a story from the Everest of Vermont, Mount Mansfield. UVM owns nearly the entire summit ridge of the mountain, approximately 400 acres in extent, most of which are above 4,000 feet. Ben Willis hiked, lugging all the camera gear, up and down the mountain to tell this story of an effort that UVM calls Summit to Shore. Here's Ben.
Vermont's weather is changing. Record-breaking snowfall, winter rain, and floods. Communities are feeling the impact. But a project at the University of Vermont is helping researchers track snowfall and snowmelt dynamics across the state. Installed in 2022, the network includes 22 stations tracking snowfall from the summit of Mount Mansfield to the shores of Lake Champlain.
I just wanted to kind of get out to this view point right here because this is where you can see Burlington, Juniper Island, Lake Champlain, all the different places.
Josh Benish, the Associate Director for the UVM Water Resources Institute, has been closely involved in the Summit to Shore network.
The UVM Summit to Shore Environmental Observation Network is a project that's funded by the Cold Regions Research and Engineering Laboratory that's focused on measuring weather and snow at different elevational gradients spanning from Lake Champlain up to Mount Mansfield and across into the Northeast Kingdom of Vermont. The project focuses predominantly on melting snow dynamics, and so how snow is melting along the elevational gradient and how it can lead to flood potential due to that melting snow.
Benish will be our guide as we explore the Summit to Shore network, and we're starting here at the top of Mount Mansfield, UVM's oldest and highest natural area. It's a fitting place to begin, not just because it's home to the highest monitoring station, but because Benish has a personal connection to this place. From a young age, he's been coming to Mount Mansfield and has developed a deep appreciation for the university's early efforts to conserve this land.
The University of Vermont acquired this 400 acres on top of Mount Mansfield in 1859. This was at a time when land conservation really wasn't a thing across the United States. It was 20 years before the conservation of the Adirondacks in New York, 13 years before the conservation of Yellowstone and national parks, and it was 3 years before the university even became a land grant institution. But the university kind of made a commitment to the conservation of the rare plants and rare natural communities that are up here by purchasing and conserving this area for scientific research. And it really places the university as a pioneer in the land conservation movement.
UVM's legacy of environmental stewardship has made research like Summit to Shore and other projects on Mount Mansfield possible.
This is the summit site for the Summit to Shore Environmental Observation Network. So we're about almost 3,900 feet in elevation at this particular location. And we have our tripod meteorological station, complete with temperature, relative humidity, wind speed and direction, solar radiation, snow depth, solar panel to charge the battery, data logger, and it's also connected to this snow scale. And this snow scale has a metal platform right in the middle that measures the weight of the snow. And so it's really important not to only record snow depth, but also to understand what the water content of the snow is. This is the data logger, and you'll see that there's a cellular modem attached to here. So we're relaying the data that comes off of this weather station in real time so that we can access it remotely.
Having accurate, real-time data on snow depth and density on Mount Mansfield can significantly impact people's lives, especially during events like the December 2023 floods.
We had a lot of snow up in the mountains, and then suddenly it rained for like a day, and all of that rain fell on a lot of snow that was up here on the mountain and led to significant flooding events downstream. And so having kind of real-time networks like this will help support the River Forecast Center with the National Weather Service and emergency responders with the state to better predict how streams will respond to flooding events that are related to snow.
From the summit, the network follows the mountain down to lower elevations, where Josh leads me to a team of graduate students working to upgrade one of the monitoring sites.
My name is Maddie Torrey. I just started my master's program at UVM this fall in civil and environmental engineering. Snow's been studied pretty heavily in the West, so we're in a really cool position to be contributing towards the knowledge of snow in the Northeast, which is kind of understudied.
My name is Jacob Ledoux. I'm a first-year master's student at UVM studying civil engineering. Today we are upgrading the base for one of our pluvios. So the pluvios are these precipitation gauges. Over here it's kind of dismantled at the moment. Really important part of these networks is being able to measure what's coming out of the sky.
But long before these high-tech tools, Josh shows us a site on Mount Mansfield where for decades Vermonters have measured snow the old-fashioned way.
We're gonna walk up a section of the toll road here just to take a look at the snow stake. It's a long-term monitoring spot where snow has been continuously monitored since 1954. We get snow measurements every 10 minutes. So here we are, the Mount Mansfield snow stake. You can see this is the old stake is to the right here. They added another stake to the side that's a little bit more modernized, but you can see all of the different foot marks that go all the way up to 12 feet. Sometimes the snow does get that high.
And just a few months later, the snow almost did get that high. During a visit in March, the stake was nearly buried, with just a few feet left above the drifts. And just a few steps away, even the summit monitoring station we had visited in the summer was all but swallowed by snow. From the deep snows on Mount Mansfield, we continue our journey from summit to shore. Our next stop, the Jericho Research Forest. Here, graduate students keep the Summit to Shore network running.
My name is Anna Gruns. I'm a master's student at the University of Vermont in the Civil and Environmental Engineering department. And I am in my last semester of my master's, and I've been working with this project for the past 2.5 years. I originally started as a research technician on the project and worked on getting all of these stations installed. So today we are visiting our stations at the Jericho Research Forest, where we have 2 co-located sites. One is in a clearing and one is in a forest. So we have somewhat redundant measurements, but we're looking at how it's different between in an area that doesn't have forest canopy over it versus under it. And today we're mostly working on fixing some of the issues that we were having with sensors. And then we also collected some manual SWE measurements, so snow water equivalent, or SWE is what we call it. And having those manual measurements allows us to validate what our sensors are giving us. Okay, so if you want to write down tear weight of 1.54. And the sensors give us a really good temporally continuous idea of what SWE is doing, but we want to be confident in what those sensors are telling us. As far as data collection goes, it's definitely been a little more difficult this year. We've had a lot of our sites get buried If the sensors aren't buried, the solar panels are getting covered with snow pretty often. At this point, like, our batteries are at one of our sites under about 3 meters of snow, which is a lot to dig out if there's an issue down there. So yeah, it's definitely been a little bit harder to monitor all the snow, but at the same time, really cool to be able to capture a historic snow year with such high resolution measurements.
Joining Anna is Maddie Torrey, continuing her work from the previous summer.
So this has been my first field season out in the snow, getting to troubleshoot and fix up some of the stations, and it's been great to learn alongside people like Anna and get a chance to get involved in the snow network. In Vermont, this is the first long-term monitoring network we're trying to set up. As climate change impacts and the world is changing, snow can have a big impact on our environment. One of the things we're particularly concerned about is rain on snow events and flooding, which has been a huge issue. Lots of people experiencing damage to homes and towns. So being able to better understand the dynamics of snow and rain and how those play out during the winter can be really important.
The network stretches from summit to shore, capturing the full range of Vermont's weather. While the core summit to shore network is complete, new stations are planned, and with continued support, that work will carry on for future generations. For Josh Benish, this effort is about more than collecting weather data.
I'm, kind of thrilled to be able to play a role in helping ensure that the research that we're doing is having a profound impact on how we care for these natural ecosystems, but also improving our society so that we can be more resilient to a changing climate.
From summit to shore, UVM's network helps us understand a changing Vermont. On the shores of Lake Champlain, I'm Ben Willis with Across the Fence.
As you saw in Ben's story, the WCAX transmitter is located at the summit of Mount Mansfield. Safe to say, there would be no visits across the fence if not for WCAX. As always, Vermont, thank you for learning and exploring with me today, and thanks to the team that makes Across the Fence possible. I'm Amy Finley. This is Across the Fence. Come back and let's learn and explore again tomorrow.